Well, for those of you that don't know me personally or know of me, my name's Keith Lostracco, which you must know from the workshop. But I've been a touch user for quite a while, not since the beginning, but like 11 years or something now. And my original background was not programming; it was chemistry actually, and then I got into music and then wanted to do visuals, kind of the regular story of the touch user. And over time, I got deeper and deeper into the programming aspect and found that is really what I like most is programming. I like making cool graphics, but I like making the knobs, not necessarily tweaking the knobs, especially if somebody else is telling me what to tweak. So I'm more of the guy who wants to build the thing for the knob tweaker. And yeah, so I've built a few different things. Like I've gotten kind of heavy into various graphics things, like fluid dynamics or particle dynamics or different types of shaders. But I've also gotten quite heavy into UI and large systems. And both I found I like whatever whatever I don't know, I want to figure out. It's kind of how it goes. So if I latch onto something, I usually want to kind of see that through to the end. So recently I haven't been doing as much graphic stuff. I've kind of been thinking about it again, but it's been more system stuff for the past while. I've built a pretty big media server in Touch that I learned a lot from, not just about how to build a system, but how people interpret systems. And now that is becoming one of my main kind of things, is what users interpret of what you provide to them. And knowing that technically you don't know it until they tell you. So understanding or being able to predict that is something that is pretty much one of the most important things that I'm starting to see in any thing that you provide to somebody, whether it's a piece of software or a house or stairs or a car. That user interface for that person is crucial. If they don't understand it, then you're not communicating. There's no common ground. So now my mode has been, I used to have all these ideas like this has to be that way and that has to be that way, and if you don't build it this way, then it's wrong. Now I've kind of started to change my tune, because it's not necessarily what I think is right and wrong, it's what the person understands. And if they don't understand it, then I'm wrong. So that now I'm starting to question all that. So that's kind of been the road of development for me now, is first figuring out the stuff and how to do things, but second, trying to think ahead. And I think Derivative's done a really good job of that. That's why Touch is such good software, is that they've put so much time into thinking about what you understand. You might want like that thing, and you might want that one, but they're just like, what about him, and him? How are they going to know what that is? Like, we got to think about everybody here. We can't just say, here you go, here's the world. Otherwise, you've got this basic, well, you have the universe, and we are kind of these organizers of systems, and without that organization, we're not necessarily following this evolutionary path that we're on of building things and building upon our knowledge of previous people. So yeah, that's kind of where I'm at. So for the workshop, I didn't really know what to do, so Marcus suggested doing this GPU, multi-GPU thing, because I kind of know that stuff. And so I'm pretty enthused about that, but I've also been enthused about some other things. So I'm hoping that the system that I'm going to run you guys through is simple enough and easy enough to understand that we'll only spend like half the time on it or so, and then maybe go into some Python tools, because that's, for me, that's a much more exciting territory than it's the GPU stuff's kind of, to me, it's kind of basic. It's like it doesn't require, you need to memorize and know a lot of things, or number of things to troubleshoot or understand some concepts, but at the same time, once you know it, it's kind of like just do it again, kind of thing. So for those of you who are just joining and didn't get the email, if you have the ability, if you want to download this repository, and you can open it on your computers while I continue, then hopefully you could catch up and be able to have it on your own systems. It's GitHub intent dev/fusion. And then there's going to be a few source files too for that. That's going to be a harder link to get to, but you don't need those source files. We could just use this repo. So for those of you that have the repo installed, hopefully you've unzipped it and everything by now, or checked it out. I'm just going to load it up. So this is a simple version. Luminosity, I learned that it was way too complicated. I didn't have time to write a giant manual. I don't have time to support it. I don't want to start a business around it. It's not really the kind of thing that I think is, there's a lot of D3. There's other things doing that job. I don't need to try and do what they're doing. So, but there is a use case for simple systems. Like over and over again, most of the clients, they just want to play this, then they want to play that. They want to play this, they want to play that. Whether it's a movie or interactive, it's just one thing. It's not layers, it's not a VJ, it's just that scene, that scene. It's mostly movies, sometimes it's interactive, but it's just A, B. So I built this much simpler system based on some of the stuff I learned, and after going over it, I built most of this in January, February. Since then, I've built some other tools, and I've kind of incorporated them into this, but I wish I would have rebuilt it again now, but I just didn't have that time to incorporate those tools. But this system, it's super basic. You basically just drop content into this playlist, and you trigger them, or you can sequence the playlist, and then that's that. Like you just trigger them. If it was sequenced automatically, you just hit start on the sequencer, and it will just run through them. Super basic, but that was the idea. It's not supposed to be something that's super complex. So if you do have the content, okay, so I'm going to go over it, and then we're going to load some content and stuff, and then we're going to crop some content. But first, I'm going to go over the insides. Or actually, first I'll go on the outside, and then we'll go to the inside. Brief overview, and then we'll crop some content, and then we'll go in a deeper description of each of the components and how the information flows. Oh, I could put the link back up for you. I'll leave it behind there for a second so you can see it. Intent dev/fusion. Pardon me? You want me to zoom it up? All right, here, I'll just go text. Can you guys see that? Got that, Barack? Okay, so yeah, so we got to keep moving because we want to keep the time down. So if not, I can get you guys all the links afterwards. But so the interface is pretty straightforward. You've got a playlist here. You've got another list of playlists, so you can make more playlists. You can select your playlist. You can select your queue in your playlist. You can start your queue. You can stop your queue. You can make a new queue that's empty. You can drag components from the network or from a list into your queue. So this is a list of components, or I could go like this. You could also have some components somewhere and drag those. Oh, I got all of them selected. Drag those into your queue list, playlist, no problem. You can also have, in this, I'm trying to make it as open as possible. You can also just drag tops in here, So you could just like queue any portion of your network if you wanted to. Just select tops. You can select components. The components don't have to have anything in them except for an out top or an audio top. It will, or not a chop. It would just look for an out and then route it correspondingly. So you don't really have to think too much. If you want to have some of these queues that run indexes and sync across nodes, then you've got to use my default queue, or at least you got to know how that works so you can route that index to all the nodes. But that's pretty straightforward. Then you have a little sequencer. You hit start. You can pause it. Actually, yeah, you can pause it. You can initialize it. You can have an end action on the whole sequence. Queues also have parameters. They've got names. They've got their sources. They've got their durations. Right now, they just pull from their source duration, whatever that content is, but that duration can be overridden, so your movie could have a different duration. It's really simple. It's not anything like Pete's built. It's just like trigger this. You have a follow action for queues, so queues can actually jump around to other queues. You can go to a specific queue if you wanted to from another queue. Just, I added that. That's kind of a little bit extra that doesn't need to be there. You can choose your audio, movie file, where the comp is that it's pointing to, if it's pointing to a comp. And you've got some levels for that queue, just super basic. But all this also can be appended to very easily. It's not like everything's written in stone. It's just like a basic version. And then you've got a master level that's synced. We're not looking at anything right now. So that master level is going to be on the output. Our left is this left preview window is a preview of what we got selected. And the right is what's actually outputting. Then on the left here, we have some bigger settings or windows. We have system settings. We'll go over these a little bit more in detail afterwards, but start all nodes, quit all nodes. A couple of these settings here that you don't really change manually, but you could if you wanted to. And a few other configuration, the audio rate, the audio. A couple just like preferences, start queue on select if I have that on. That should start when I select it. Typically, you'd hit take or start. I've called it start, but maybe it should be called take, depending who you are and where your background is from. Output, there's some output levels for your output. Playlists, you can save a whole set of playlists. You can load a whole set. Sync, status. So this we'll get into a little bit more. This is some information back from the nodes. It's not doing anything now because we have no nodes running. Oh, I never deleted the second one. There should only be one sync there. Node status. So this is some other status based on the node, not having to do with sync, just like frame rate, how many dropped frames, how much memory we're using. And here's another kind of important one, the video converter. So if we're going to be playing content from, that's going to be canned content that a client's going to provide, we've got a whole giant canvas, and we're going to have to crop that into multiple pieces so it can be played on multiple nodes. To me, a node, just to be clear, just before I go on, a node is an instance of touch. It doesn't even have to be bound to a GPU. It's just an instance of touch. So a node, you can have two nodes on the same GPU. Typically, you're going to have one node per GPU, and you're going to have maybe multiple GPUs in a server, and you might have multiple servers with multiple GPUs. And maybe on the primary master, you might have 2 or 3 nodes running on GPU 0. One of those nodes will be the UI. Another node could be a preview node that's just playing a preview movie. And possibly that's going to be the master sync node, which is not the UI. So when you click on something, it's not affecting your sync. And then you might even have a third node, which is just plain audio. So audio is not affected by video at all. And this system will do all that. It's pretty, it's a much clearer way than the luminosity way, but there's a lot less tools. There's 0 mapping tools in here. If you want to map, you got to roll your own mapper. You got to do it all yourself, but at least you can do it. Like, you don't have to figure out how to do it because you're a touch user and you know how to map. So it's It's not an issue. But so that's the overview of the interface. The overview of the inside is you've got a few main components. First, I'll just start on the left. You just got this modules component, which is where all Python modules reside. I'd like to keep all my Python modules in one spot for the most part, unless they're meant to be changed on a per component basis. And if they are, then they sit in their own component, but otherwise they sit in modules. Master comps, that's just you've got the initial default playlist in there, the initial default set of playlists, and the initial default queue. And that's all that's in there. It's just a place to copy and create from. Then you have playlists, and that's where all those playlists reside, and they're all literally components. And then inside of a playlist, you're going to have queues, and those are components. And depending on what the queue is doing, there's some stuff in the queue. If it's selecting a scene, then all it's doing is selecting a scene. Your scene resides wherever you built the scene. But if it's a movie you loaded in there, it's playing inside the queue. And then you have cross. Cross is kind of important. It's pretty minimal, but it basically selects the current queue and crossfades, selects the next queue, crossfades from the current queue to the next queue for both audio and video. And you have your output, which is basically not much except for some levels. There's not much going on there. You've got your UI, which is kind of important. UI is all UI. No UI resides out of UI. It's all inside of UI. Try to stick to the model view controller paradigm, although it's not super strict here, but it is basically view. There's literally an extension called controller. All commands go through controller. And then there's the model, which is a conglomeration of extensions. And then there's data, which is either storage or parameters. Sequencer is just a little basic sequencer. It's just a timer that just triggers those queues. It's just super simple. Automatically make a segment stat out of those queues. The video converter is its own thing. Talk about that a little bit deeper, but it converts the videos. Devices, there's not much going on there. There's just an audio device in right now. If there was DMX or there was OSC, if there was some sort of sensor, I'd probably put it in there and then know to select from that. I'm going to the last two most important. The last two are the most important. Then remote, I'll go to config after remote. Remote is kind of like the most, it's what everything is going through to connect to everybody else, basically. It's not the most important thing, but it is as far as all the nodes go. So remote is basically a TCP/IP DAT, and that's the extension of a lot of the controls, so there's no more to it than that, besides its extension. And then a sync component, which could be even more limited than this, but since I assume that most people wouldn't have Pro for the workshop, I've set this up so it can use shared memory or touch in it or out, or I'm going to switch mine to use sync. And now, oh, sorry, wrong button. Now I'm using sync. It created those sync nodes. Sync nodes cook no matter what. Like, you can bypass them, you can turn them off, they still cook. They cook less, but they cook. So I delete them and I recreate them if I don't want them there. It's just, we can RFE it or whatever, but sometimes it's just faster just to roll your own solution and just be like, that's how it is. So right now I'm just, these switches just switch. We're using sync, but we'll go deeper into that afterwards. And then we have some status stuff too, so we get some talk back from our nodes of some messages back of what they're doing and what their state is. And then config is kind of the most overall important for all the nodes. We can say how many nodes we want here. We can save all the nodes. Nodes are our talks. Literally a node is two things, or I could be referring to. It's an instance of touch running on some computer somewhere, but it's also a talks. It's just a talks. And that tox gets selected on startup depending on some environment variables that get set when that instance starts. And so nodes, there's just, it's much simpler than previous systems. Nodes have a number of settings. I'll go over this a little bit in detail right now, so it gives a good background for afterwards. A node has an IP address. It's got to live on a particular server. A node has a server index, has a GPU index. If the GPU index is set to -1, then the GPU, there's no affinity mode. There's probably only one GPU on that computer. Who cares? Don't try and say GPU for monitor, because it might return saying that you can't do that. So set it to -1, and it won't load that node in GPU affinity mode. Although that doesn't seem to be happening anymore. That was more of a problem in the previous way of setting GPU. But it's there anyways. And monitor is the index of the monitor for which that node is going to be, its first monitor is going to start on. So if there's 16 displays on your computer and you set that to 3, it's going to be on the 4th display. 0, 1, 2, 3. Yeah, so 0, 1, 2, 3, it's going to be on the 4th, if that's on 3. If that's on 4, sorry. Window size is going to be your window component size. That's the size of your whole node's window. So typically, most people that use Touch for a while know that you don't want to have multiple windows open. So we have one window, but we might have 4 outputs in that one window, which are going to be 4 container comps being viewed by that one window. So this window size, if this was a big node, could be 7680 by 2160 or something. And then it would have multiple containers within that were 4K or whatever, or 1920 by 1080. The window offset is if you want to move that window within your desktop. And that can be useful for certain cases. Like this case for the demo today, I'm going to move the outputs to different positions within the window. Then render canvas, I'm not going to talk too much about, but that's if you have 2 different source files for 2 different, completely different maps. And so every node can play more than one source file. So for instance, if you have a mapping or some sort of installation where you have one map for the walls, you have a whole another map for the ceiling. You don't want to like put that in a rectangular map because it's not round or anything. It's square, so you have 2 video files and they're like both 20K each. Now you can say each node is only going to run this from this one, or it's going to run from that one, or you can make 5 of those. Kind of make it what you like. Canvas size is going to be the size of the render canvas that you have selected. So if you have 20K output by 8K or something, that's going to be your canvas size. Whatever that total raster is, that's that size. The node render size is going to be the size that that node renders of that canvas. So if it's 20K by 8K and you're going to render 5K on this node, you're going to set that to 5K by 4K. Then the node render offset is going to be where in that canvas. So you're rendering 5K by 4K, but you're rendering the second chunk. So you're rendering from the 5,001st pixel to the 10,000th pixel. And you don't have to say crops here, you just offset it. It does crop eventually, or depending what you're doing. If it's a render, you're not cropping technically, but so it's called offset. Then a node also can be the master. So that's is master. So am I the master? Am I controlling everybody? Node could also be or not be master sync. So am I syncing everyone? And the master and master sync don't have to be the same. Master is the master controller, while master sync is master sync. In our case, master sync and master controller are the same thing. The UI is master sync. Typically, I would never do that. Preview is master sync. I don't want any clicks from me affecting anything. I just want them to tell everybody what to do. And you'll never get a UI fast enough to not cause frame drops. Or maybe you will, but it's going to be like 2 buttons or something. It's probably not ideal. Then you also have another value here called is preview render, and that one is you need to probably have some sort of preview output. So if you got a 20K file, you can't play that file on any node, or you could, but you don't want to necessarily. So with this cropping system, you're going to render, you got that 20K raster, you're going to render a 1920 version of that aspect scale correctly, and that's going to be your preview render. So when you trigger it, you have something to look at to give you feedback. Or even if you're editing, you're making stuff, you could render, you might not be, we had one show, you couldn't do anything in the resolution. So you had to do all your building all at the preview resolution. Then push it out to your nodes. Does it work? Yeah, it looks great, okay, or not. And then back to your actual, you're running in 1920, it's all running at 60 frames. It's like no problem. Then his backup, that's not really implemented in this right now, but it's for future use, so you can quickly switch to a backup. Does it output video? Yes or no? That does work. Does it output audio? Yes or no? So a node might not output video, might not output audio. Because I use PS tools, we have to have a username and password per computer. PS tools, I can't send commands without them. So I found there's a way, I'm not going to show you now because I didn't write it down for this, and I always have to go find it in my previous notes. But there's a way to make Windows not start up with a username and password, but it still has one. And so a lot of times I'll do that because people don't want that username, or sometimes they do, but sometimes they don't. And then there's this last one, which is kind of important. It's this move file postfix. And what that means is, I couldn't think of a better name at the time, so it's the most descriptive name I could think of, is it appends, for when we crop all these crops later, we're going to append all the files with that name for that node. And so when that node loads those files, or loads that movie, it's going to replace the preview name with that name, so it loads the proper file for that node. You'll see what I mean in a minute there. So that's basically the node configuration. So you've got all those settings to basically, it takes a little work, it takes a little time. For this one, this is master. It is the master, it is master sync, and it is preview render. It's not outputting audio and video. It actually is because it's still preview, so that kind of overrides that. The preview, the window size is 1920 by 720 because that's what my UI is. The canvas size for this, for the entire, the canvas size for all these is the same. Really, canvas had to be on per node because if you have different zones, canvas has got to be on per node, so I can't make that a global thing unless you have these multiple zones above, so I just put it per node. So canvas size for this workshop is 1920 by 360. The node render size, I was on master. The node render size for the preview node, which is what master is half that. So my preview for this is 960 by 180. Same aspect ratio, half the size. Node 1, its window size is 480 by 360. Its window offset is 0 by 720. I'm putting it up in this top corner. Its node render size, its canvas size is going to be the same. It's 1920 by 360, same as the others. Its node render size is going to be 480 by 360. So right now, my node render size and my window size match for this one because my node is going to render to the full size window that's being displayed. And none of these are on because, yeah, my output video is not actually doing anything right now. So they don't have to be on. This is the same as the previous, except it's moved over 480 pixels. So it's up in this quadrant right here. Exact same settings. This one I made a little different, just to mix it up a little bit. This one is 960 pixels wide, and it's moved over 960 pixels, so it fills up a whole top right quadrant. And its node render size is 960 to fill that up. And both of them I didn't specify here. They're offsets. This one's offset 480 pixels because it's the second render. This one's offset 960 pixels because it's the third render. So in that canvas of 1920, I'm rendering this one, I'm going to render this one, and we're going to render that one. Just like that. And that's what those settings are. It takes a little while to like think about those and get them in your head. And once you get into it, you're like, you can maybe make some UI and make it easier, like Resolume or somebody or D3 or something. But all you really need is those numbers and able to think about it. But if you do have to think about it a little bit, even though it's straightforward. One more thing before we get out of nodes is inside of nodes, we have the full container that gets selected by the window comp in perform mode, and we have the output window container itself, which has a size because the output can be only part of the window. And in our case, the output is in this node is the same as the window. It's 480 by 360. Let me just throw a quick file in here quick, just so we can see. And node info. Oh, so let's just look at that quick. That's our raster. And you can see that we've got node 1, output 0, and its settings. I put them all in the text file, text top. Node 2, output 0. Node 3, output 0, has its settings. And then notice the difference with node 3, same node, output 1. And that's the example of outputting a different output of the same node, which is a typical case. So if you've got one quadro with 4 outputs and 4 projectors, you've got to actually output 4 windows because you have to calibrate 4 projectors. You're not outputting one window. You've got to output 4 cam snapped or however calibrated to that projector. So you need to have 4 in that kind of case. So in here, we've only got 1 in node 1. In node 2, we only have 1. Or sorry, what's going on here? Looks like we've looks like my yes, okay, we're looking at the wrong node now, so we're not looking at this correctly. This is one thing I wanted to do is I haven't made this so it switches its way of viewing when you're in master. So right now we've got a preview render here at 960 by 180 and it's cropping 480 by 360, so we're actually looking at 2 nodes. Normally you wouldn't look at this. In Luminosity I had a whole system for switching for that, but this I didn't do this because my plan for this was you don't do anything in here except for on the actual node, because I didn't want to build a system that people had people are used to working in the computer they're on, typically for the most part I found. So I made this so you're going to work in this Tox after you set those top level settings right on the node with TeamViewer or directly on the node. So right now we're outputting out of a preview, and that's not viewing what would, but on our node, I'll show you afterwards, this will be correct. But in this one, we're going to have 2 windows, just if you ignore what's actually in the actual output. This one's 480 by 360, this one's 480 by 360, but it's offset by 480 pixels within the window, which is 960 pixels wide. So that gives you the rundown of of the nodes. And now what I'll do is I'll just start this up, and then I'll get you guys be able to crop these. I'm actually going to, because we're out of sync now, I don't have a way to, well, I could hit save. I don't want to hit save though. I want to start fresh so I'm in the same position as you in a second. I'll start the nodes, and then I'll just give you a brief rundown how to crop them so you guys can play the nodes on your own computers. Hopefully it all will work. So now what I'll do is I'll hit Settings, Load All Nodes. So now what's going to happen is I'll describe this in further detail, but what we're doing now is we're running a popen command in Touch Designer. Well, first I'm running one function that determines whether the node is local or if it's on a remote computer. And then that function realizes that that node is on a local computer. If it does, then it runs a popen command that runs a Windows command that starts touch with a few variables. So I don't use any batch files. I just do it with Python. So I'm calling Windows commands with Python. And so I've just loaded 4 nodes. You can see my desktop disappeared, or 3 nodes. And now, if I press play, now we're looking at 4 different instances of touch playing the same file in sync. Not the same file. They are playing the same file. We're looking at a component right now. That's not a movie. That's a Touch Designer component. So they all loaded from the exact same project. They've all configured themselves according to their environment variable settings, and they're all selecting their corresponding node and doing their proper crops based on those settings. So if I go like this, if I hit escape right there, I've just minimized that node. Those are one window there, and a third window there. And those windows are now in sync. They won't be because I've minimized that, but now they will be. So now they're in sync. There's a whole framework inside that we'll go through in a second, how that's happening, why that's happening. And there's different levels of what's going across. Soon, if all goes well, we're going to be able to send messages across the sync chop, which will be a huge bonus. If we can send messages across the sync chop, then the system I've got, I had to do some hacks into my like model view controller kind of simplicity, like super easy thing, just to be able to queue nodes, which is kind of a bummer. So once we can get sync messages across sync, then there'll be almost nothing going through sync except for indexes. That's it. And maybe channels, some channels, but probably not, because we just sync par value functions. But quickly, so you guys can get a little bit of a handle, if you have the files, for those of you who were able to download the Google Drive folder, those files are here. For those of you who only got the repo just now, those files, there's only 3 of them. I only saved the image files. You won't have movies, but at least you'll have the images to go through the process. They're in test content render inside the repository. So there's 3 image files there. I'll go back to these source files here. To crop a source file, did I quit all those nodes? I'm just going to quit these nodes just quickly. Good. So there's a quit. So I'm going to go to convert. So now I'm opened up the video converter. This guy's kind of key. Like, if you don't have this, then you got to ask your content creators to do this. You got to ask the client to ask the content creators to do this. They all get very confused. Nobody really understands. They do eventually. You explicitly say this has got to be that, but there's usually back and forth. But if you could just say, hey, give me a 20K file, end of story. They send you a 20K file, whatever it is. You load it into here. We can automate this. I went to make this a batch converter, but this runs on its own local time for the index, and it was just going to take too much time at the time, so I didn't bother. I didn't have time at that time, but basically you load your full canvas file there. You select an output folder. I'm just going to say test. Select that, and then you hit start conversion. And so now it's cropping that one file into 3 files. And if we had all our IP addresses set up correctly, as one fundamental thing that I found quite crucial and quite easy to deal with is when I set these addresses here, the project file and the project level assets, like the static assets, can all live in the project file directory, all on master. So let's say mdrive/fusion or whatever / my project. They'll all live there. Project file lives on mdrive/fusion, whatever. So when you go to load the nodes, it loads directly off master. All your computers are networked together. It just reads that drive over there on master. There's only one project in one place. But if you're playing files, the whole point to having different servers is, one, to be able to output those files across those pixels. Those files need to live on their respective nodes. So when you set this IP address, I've disabled it here because there can be problems if you have sharing enabled on your drives. So whoever didn't have sharing enabled, this would all break. So I just commented out the code for now. So it's going to render to a local specified drive right now. But I commented in the code that you should comment this out. If you comment it out, what's going to happen is it's going to load to the same. I made a choice to keep the drive letter the same. We could make a drive letter here, or media drive specification here, but I made a choice. When you crop out all those nodes, it's going to render directly to your drives on all your nodes. So that little crop here, if we had a computer over there, it wouldn't write it to this computer at all. It'd read it from this computer, but it'd write it right to that mdrive/media over there. And all those nodes will have to have the same, they will have the same path, because if you use the converter, it will make you use the same path, and it will make the path for you if you didn't make it already. And you'll write to m/media on that computer for whatever that video was called, ramp radial 2. It'll be ramp radial 2 on that node, ramp radial 2 on that node, ramp radial 2 on that node, and they'll all be appended with that move file postfix in their name. So that will be ramp radial 2 underscore node 0 here, ramp radial 2 underscore node 1 there, node 2 there, node 3 there. And they'll be all on different computers right away. So you don't have to talk to the client and tell them, oh, we got to wait, we got to do this, or you got to crop it all. No, just deliver the file, hit render, end of story. So you can do that if you guys want to. If you want to see some stuff work, you can do it with a few of the files. The solid ones, the TIFFs, you can hit render, or you can hit just save images, whichever you prefer. If we go into source files /test, all my files should be there that I just converted. So I'm rendering the same folder because we only have one computer, so we don't need to go to all those nodes. And then once you've done that, I've got all my videos converted here. Actually, let me just start all nodes. I'm going to start all nodes first before I drop anything else in, because I'm not doing any tests of sync on startup. If you really wanted to, you probably should. You don't need to in a lot of use cases because you're kind of aware of all that. You're only ever really saving master unless you're saving mapping, and then you're going to save the talks for that node. So right now, this is saved in the same state of what I just loaded up. And now I can drop all my note, if I just get rid of this. So here's all my crops of all those movies that I did previously. And we're on preview, and the way I've made it is it does a replace with the preview postfix. So I want to drop the preview movie onto the master, onto this UI. I can actually change that name to preview if I wanted for more clarity. For this, I left it at node 0 for a different type of clarity to remember that node 0's master. So what I would do is you could go like this. If you were working across multiple machines, you wouldn't have all these files in the same folder. They'd be, like I said, all on their respective computers. I could do that, or I could just go in here and I could just say node 0, which is kind of a nice. Oh, it's not filtering. There we go. And now I can select all those files, drop them in my playlist. and hit start. And now that's a component we're looking at right now. That's a touch component. I'll go over some of the cropping stuff with that. It's a little bit different than actual video files, quite a bit different. But now that's a video file. Here is that node info file right now. And if I was to go into this node now, and we look in that component that I saw what appeared to be a problem, which is technically kind of a problem for user interface because it's hard to understand, but it isn't technically a problem because it was never meant to work that way. But now that I showed it, I understand that it needs to be dealt with. Now, here's the render, 960 by 360, I think, 960 by 360. That's our container. The render is actually being selected here. Let me just go up here for a second. Here's our actual cross, and here's our real resolution there at the end. 960 by 360. We're in node 3, so this component's being used right now. This output is selecting the 961st pixel over in our 1920 full canvas, and this output is taking just 480 pixels of that, because if we were projection mapping with a projector, we just want that one window. And so you can see here's the full 960. Goes through this just simple 2D crop. You could change this. This is all meant to be changed. It's not like written in stone. This is all like do it how you want to or what you need to, depending. If I was doing projection mapping, I wouldn't do that crop. I would do it all in my shader and just change my UV coordinates. Skip on the crop. Well, I don't want to use that extra crop when I could just like say 0.5 for you. Much simpler. Or at least 150 less microseconds. And then you can see here, this guy's got an offset of 480, so we're actually taking the second part of that node render. And we're cropping that chunk. I put my edge blend in there anyways because I didn't want to lose it. It's kind of a nice edge blend. It does all sides and do angles and stuff. But there's no mapping in here, so you roll your own mapper right here somewhere, or bring Cam Snapper in, or Stoner, or whatever you're using, or your own tools. You'd bring that in somewhere in here. I never did it for here, but I use this 3D mapping thing. This workshop's not about mapping, but it's worth taking note of. Mapping on your UV, on your input to blending on your input is much better than blending on your output. So if you blend your texture source for your Cam Snapper model, the texture source, not the output of Cam Snapper. Now all your blends, you have to do all this stuff. Like it's got this crop, or where is it? Offset. You've got like offset within the texture where your blend isn't with the texture because you got this 1920 wide texture here, or whatever, 960, and you only want this 1/2 that we got here, so you got to like move your blend way over here, so you're only blending that edge within that full texture. But however your model is, your blend is going to go like this, and when you map and calibrate, you don't touch your blends. There's no blending on site. It's all done because you've blended on your input to your texture and you've overlaid your textures perfectly. And then on site, there's no blending. Like it's blending, but there's no work. There's zero work for blending, but you have to calibrate. And that we don't have. That's a whole other kind of little workshop, but it's actually really easy to do. You just remember to like put your blend on your texture, not on your render, and it will work perfect. The last BlizzCon took like 4 hours to map the whole thing. So we just pointed the projectors. It was pretty much there, and I just had to tweak every point, pretty much every point, just a little bit, just to make it there. But never touch the blends, not once. And so yeah, so that's the cropping of that. And yeah, now all these, we'll go through the indexes in a second, but before, we're still talking about cropping now. So before we go too far with any of these indices, and the whole control paradigm, I'm going to just talk about this cropping just a little bit more, because it's quite important, especially for most of the people here. I think you want to do real-time rendering, like you probably don't care about movies as much, although your clients probably care about movies. That's why I built this. It's like, but you have to crop 3D. And cropping 3D is easier said than done. Derivatives built some tools to do that. They're not necessarily the most intuitive tools. So I just roll my own projection matrix that's really easy to use. And so what we could do is, because you got this render now, you've got a 1920 by 360 render with a, whatever that is, 70-degree field of view. So you can't just like point the camera here and make the render like that. That doesn't work. Like that's this field of view now in that direction. You need this direction with this field of view rendering that. And so the camera component and the render component, or top, render top has crop settings and resolution settings, and the camera component's got window X, Y offset, and you have to have it in focal point mode, not field of view. And you have to tweak all those settings to get that crop. Like, and it's not overly intuitive. It's kind of a pain in the ass. Every time I go to do it, I'm just like, I can't remember, and I have to like figure it out again. But before that was even there, I built it for luminosity, and it's just a simple offset in your projection matrix. Super easy. So I built in luminosity, so now I never use that. No offense to the people who built it, but it's way faster just to set 480 pixels. Done, right? So in this component, I've got the scenes component that has those comps that you're able to drag in the queues. These are special comps. They inherit from I think they inherit from a QComp class or a scene comp class. I can't remember what it's called right now. QComp. They inherit from a QComp class. We'll go over that in a minute. But before that, yeah, we'll have to go over the class a little bit almost at the same time. But long story short, this camera here, you don't set any settings on this particular camera. It just selects the projection matrix. You can move this camera. It's all based on its position, but you can't set its field of view here. You've got to set its field of view up here, and you've got to set its projection type there. And those two settings there get used by this class. I'll open this. Well, this guy actually doesn't open in the editor, and I don't want to break with the sync thing right now, so I'm just going to leave. I'm talking about the DAT sync deal. I'm just going to leave this like this for a second because it's not quite as important. But in this class here, which is set to default, you call my function. Where do we call it? At the bottom, right here. math.func.mapmath.calc.projm, and you tell it the field of view, you tell it the resolution of your whole canvas, you tell it the near and far clips, you tell it crop left, you tell it crop right, you tell it crop bottom, you tell it crop top. And one's for ortho, and one's for perspective. That should actually be called calc perspective matrix, not proj matrix, but it is called that right now. So you just feed it those four numbers. This one, instead of field of view, you got to give it ortho width. You just give it those four numbers, and then if we go into the node, if we look at this scene, now we're rendering 960 by 360 and half the field of view in the right direction with the right camera position and the right field of view. So you're rendering like this, not like this. And that, to me, is much easier than dealing with this setting in conjunction with this setting in conjunction with this setting with the fact that this setting here is set the field of view. It's just like, yeah, it could be a RFE to change, just put that in there. It'd be much easier. But that's in that. All this is free. Well, most of you have downloaded it by now, but it will be available to download people could use it. They're good tools to have. I'll go over that a little bit in a second. So that's the basic. I probably went. I don't know if I've gone too fast or if it was too much, but that's the basic node cropping and node canvas, render canvas kind of methodology I've come up with. There's still, I'm sure there's better ways. There's always better ways, more refinements, but that's the clearest I've come up with so far for myself. If anybody has any questions, I'd be happy to answer before we go on to the next part, which is kind of another level in the control aspect of things. Okay, I'll keep going then. Oh.
It seems like all of these projectors are kind of shining on a surface that's all the same kind of focal distance from the camera. Like they're all kind of parallel plane. But is this going to help in the case that maybe one projector is shining farther than the other, or maybe one surface is rotating from the other?
Not if you're calibrating, no. No, if you're going to still have problems if your surfaces are far and your lumens, like you're going to have your real physical world problems. That's not solving any of that. Like as far as like brightness and gamma, definitely any angles. Like there's a certain threshold of geometry when you're projecting on an angle where your pixels are getting stretched. No matter how well you calibrate, those pixels are that long and that high. Like that's not working necessarily. So but that's a physical limitation that you've got to either work around in your set or physically. But as far as perspective and as far as mapping goes, none of that matters. As long as you calibrate, as long as your projectors are, everything's accounted for, everything should line up and will be synced. But yeah, as far as gamma, black levels, pixel stretch, like all those things, those are all physical things that, well, first, usually projectionists handle. Hopefully they handle white balance and all that. Like I usually don't like to touch that. They do a really good job, and they spend hours. And usually you're the only guy who can map, so it's that guy's doing that, you're doing that. So it usually works out pretty good. But yeah, no, you shouldn't have a problem with any of these crops and stuff like that. That doesn't. I've never had that issue. Yeah. These are all in classes, and they could all be called. All those modules, most of these modules can stand alone, especially those ones. So they're all in here, and they're all like, I edit kind of in, this is the way we're going to do this now anyway, so I'll open this up. This is the way I like to edit in Touch Designer. I don't open files anymore in Touch. I just right-click on the folder and select Open in Code or Sublime or whatever. And then usually I like to work in a bigger monitor now, but usually I'm going to make that a little smaller. Usually I work like this now, but a much bigger monitor. So I just got my text here. So these are all my modules. And so if you want that function, all you have to do is go into Kmath, copy the whole file, and I've got two static methods. One for the perspective matrix, which probably should get changed names, and one for the ortho matrix. And you just got to feed them those parameters. You're going to have to hack it out. Yeah. I have another project. There's a few broken down things, but this one, it's super easy to hack out. It's not luminosity. This is not luminosity. Like, it's super simple. We're going to go in the network now. It's super easy. I'm just going to make that a bit bigger because that's just too much. Okay, so yeah, the system structure and how nodes sync and parameters sync, which is kind of a huge thing. This is my favorite so far that I've done. I have an even better idea now that I have this other thing, but that can even make it even a better workflow. But I probably wouldn't do it until we get that sync chop anyways, because once that sync chop comes in, then it's just going to be like no problem. But for the most part, what I've tried to do is, and we look here, just takes a second. So what I've done is I've broken these out into what are kind of model view controller functions or classes. And these still aren't necessarily the model. The model's kind of the components. The model's kind of hard to say really what it is in touch, but it's definitely not the view. You can say that. That's the view. That's it. FPlayer, UI, EXT. And the controller is really the controller. Controller's pretty clear. Everything gets routed through, almost everything now gets routed through controller. I'll go over that in a second. And remote and sync extension, those are both controlled by controller. Node, that is not an extension. In my system, now all modules are all lowercase, 100%, no underscores. All classes are upper camel case. All functions that are public functions are all upper camel case, and all non-public functions, touch, derivative, enforce this rule, are all lower camel case. You can't get around that, but as far as extensions go, I know what an extension is because it's got an EXT on the end, and I know what a module is that's not an extension, that is likely inherited or has an object that a module creates dynamically, has no EXT on the end. So I know node and system are both just modules. They're not necessarily, they're not extensions. They're probably used by extensions, but they're not extensions. So I know that just by the names. And I like that. It doesn't matter what names you use. To me, this is just what I do. And I've recently switched this. It's kind of a pain with the component editor because it makes all capitals. And I know Jarrett wants us to all kind of be on the same path, but I don't like the class name being the same as the module name. It's too ambiguous. The module is the module. The class is the class. You could have more than one class in a module. They should be distinguishable. To me, it's just, that's what I've kind of decided for myself. Other people could have different perspectives. So right now, you have the main kind of two classes. I'd like to switch this so one inherits the other. Specifically, FPlayer inherits controller extension, and controller is no longer an extension, but right now there's two extensions. But I think player should inherit controller. Player is the system, while controller is the controller. But we have two here. Everything kind of goes through controller. FPlayer extension is kind of some main settings and some main properties. All commands that typically only really come, except for some coming out of the sync chop, all commands come from UI or sync. If they're on master, all commands pretty much come from sync, UI. And if you're not master and or you're a preview, some commands may come from sync. Because, well, if you're not preview, all commands definitely come from sync because there's no UI. You're just rendering. So they're all coming from sync. But all commands from UI, they don't control any of this directly. They all go to controller first. And controller decides who and how that command gets routed based on what node that controller is part of. Because now we're talking about I'm master or I'm some rendering node. So if I'm master and I'm not rendering a preview, I'm actually just sending information out. I'm not doing anything internally. Or I might still do something internally, but I'm definitely sending information out, depending on what it is. So if we just look at, let's say this guy, for instance. So we got these new start stop buttons. So fplayer.getAtter, qstart. This is capital uppercase. This is more of my naming convention. So this is not Python getattr. This is my getattr, upper camel case. So you see all these functions here, or all these buttons, they all call a function called whatever they are in fplayer. Fplayer is a parent shortcut. I put the parent shortcut outside of the defined because I only want that to get set once. Parent shortcuts, op shortcuts, internal op shortcuts, they're all slow, in my opinion. Not even my opinion, in my tests. They're not that slow, but if you got a lot of shortcuts, do you need that overhead every time you call a function just because it's easy to type in the function or the parent shortcut? So a quick workaround for that inside of an extent or inside of a callback like this is to put it outside of the define. If you go to change this, you've got to make sure it cooks somehow. If this can't change dynamically. This will break if this were to change dynamically because this got set when it was compiled when you clicked outside of it. So you got to understand that before you do that. Otherwise, you could be in some system where you're a situation where you're like, this isn't working. But given what I just said, shortcuts don't usually change, so it's not usually an issue. So now this is calling getattr in fplayer, and that attribute that it's calling is qstart. And then this is playlist initialize, and this is qcreate. And then if we go now now remember that controller and fplayer extensions are both extensions on fplayer, the main component. If I go to controller now, we can see I've got these kind of broken down in their various zones. We've got this qstart function here. But it didn't call that qstart function. It called getattr, right? And it just said getattr here. It didn't say anything else, just qcreate or qstart. So if I go down here now, I got to put this mini map back on. It's too small resolution. So if I go down here, here's my getattr function. Now this is the whole kind of key. So we're going to go right to remote after this. Getattr accepts an attribute, some args, and some quargs. For those of you that don't know what args and quargs are, they're actually just they don't have to use that. They don't have to be that word. The key is that there's a star in front of args and asterisks, and there's two asterisks in front of quargs. Arg stands for arguments. Quarg stands for keyword arguments. What the asterisks and the double asterisks do is they inform the function that your list is actually a list of arguments, and to break that list into various arguments for your function. So don't take it in as a single argument. Take it in as a series of arguments, or a dictionary of arguments for quargs. So now, getattr says if self.control internal, control int, getattr, like real Python getattr. Just get that attribute, whatever it was, in me, self.ownerComp, and the attribute. So that was qstart. So it's going to literally now call qstart in itself. And now, because I have some functions, I should go over that a little bit. On startup, there's a few various modes saying, am I local control, am I external control, am I local and external control? These all get set up on startup by another module that is inherited by controller called system. And so these all get decided on startup down here with these properties. I won't go too deep right now into that. We'll go back. I'll just stick to this so we don't lose track of what we're thinking about. So master called itself because it knows it's master, and it knows that it needs to control itself because that was configured in the node. But then, if I go back down now to getattr, since master is also controlling external, this has been set to true. If control external, if that's true, self.remote.getattr. And now that's the key to my whole communication thing. I've built a small version in the other repository called ID Tools that has that just broken out by itself, so you don't have to like kind of rip this out of here. You could just grab it and understand it. I'll show you to it a little bit clear. Actually, now's probably a good time. I'll show that a little bit more clearly of what that does on its own. But now that function in remote, getAttr, you send it a component, you send it a string, which is an attribute name. That should be called attribute name if we want to be a little bit more explicit. You send it the args, and you send it the quargs. And now in attribute, and now in remote, it has this function called getAttr that takes those 4 arguments. It pickles them, so it serializes the bytes, so it can be sent out over a message. You can make it like a text message too, but pickling it's nice because now you can send a function. You can send an actual object, a pickled object. You send the pickled object out TCP/IP. That's it. Done. Then on the receiving end of the node, it receives bytes. This gets called by the TCP/IP on receive. It takes in the bytes. If not self.fplayer.node.is_master. So if I'm not master, then data equals pickle.loads, unpickle it. Then I have a little lookup list of 4 functions, or 3 functions in this one. And what I did right here, you can see this index here. I put an index in each of these. setAttr is 0, setPar is 1, getAttr is 2. So in self.remote functions, get the first item of data as the index. Sorry, this is the other items, the rest of the items. Get the first item of data, which is the index to call. So it's just a little lookup. If we look up here, here's those remote functions. There's 3 functions there. Notice there's no parentheses on the ends. Technically, you could call this a function pointer, but we're in Python, so it's actually just a function without calling it. It's the function object, a reference to the function object. And so, yeah, that little guy selects the function, passes the data. Since we call getAttr, I break it down. You don't even have to do these lines here, but I do it so for clarity, so you know that the first one is comp, the second one is attribute, the third and the fourth are args and quargs, and then you call getAttr again, and that's it. It's just like, just get the attribute. Derivative pointed out, or I think Rob or someone pointed out that I should probably not use getAttr, because technically you're not getting an attribute across the node. You're not even setting an attribute. You're calling a function when you're using getAttribute in this case. So maybe it should be called call function or something. But setAttribute is legitimate. setPar is legitimate. And getAttr could be a different name. But yeah, that's the essence to all communication. So now, anytime a par changes, anytime a function's called, it calls getAttr or setAttr or setPar, and it sets its instance wherever those instances are. And that's it. There's no other routing. There's no other need to think about how to get this data from here to there. It's just like getAttr, setAttr, setPar. So you put a par execute wherever now. You can pass the owner, pass the name, pass the value, and set pars everywhere. There's no touching, out chops, none of that. But this data is not synced. So the only data you could do for this is setting stuff. You can't really do sync critical data with this until we get that message over sync chop. And once we do that, then you can just use the sync chop and remove the TCP/IP data altogether, and that'd be a bonus. And you're just like, everything is just getAttr, just whatever. So, but that one, I'm just going to load up because this is kind of fundamental. I'll go to the simple version just quick. This guy, and this is, I put one extra function in there last night because I was like, this is good to know. It's a little bit on the, it could be used for nefarious activities, but it's pretty cool because you could do things that you wouldn't necessarily think to do, or I wouldn't. So here's that remote extension or component, same component, just slightly standalone on its own. I have the same, oh, I'm pulling it in from a modules dat, same as before. It's actually called IDM. Where's remote? So it's here, it's almost identical. And I've got the same functions, but I got one more called execute code. And execute code is a little bit different, but the same. And that one, so now, oh, here we've got to go like this. I got to manually start up another instance of this guy. Hopefully it won't be a problem with Fusion running in the background. They should be on different IP address or ports. So now we got this guy. I'm just going to put this here. You've got this little comp. Oh, wait, I got to switch this now to it is not the server. It's the client. And I got this little example component there. And I'm going to open up a text port so we can see some stuff print. And so now you can see here, I've got a par execute inside. And, oh, that's the extension, sorry. Oh, no, the par execute's on the outside right here. Op remote.set par, par.owner, par.name, par.eval. And now if I change this, we're changing that value there. I change this, we're just changing that string. Not too big of a deal to look at, but it works for all nodes across all components everywhere. So you don't have to do, all you have to do is have that par execute. But here we got a couple scripts. This is just simplified version of the Fusion one. Remote.getAttr, there's a function inside of this remote example. I got two functions. One's called sum function, and it's going to print some function called remotely. And then I got some function args, some function, that should say some function args called remotely. Val1 and val2 gives the args. So here I'm going to run the one that gets getAttr. Now we're looking at this text ports with the other node or instance. Some function called remotely. Hello there is the args. Oh, that was the args one. Oh, they're both args now. Oh, well, they're both args. But yeah, so they're both just calling that function. But here's the new one. I did this a while ago, but I put this back. And it's pretty cool. Like, it could almost have no use case. Like, why would you do that? But there could be a use case, especially if we're deploying like 500 computers or something, and they couldn't go down. Like you couldn't restart them, or maybe you didn't have the tools to restart them or reload something. You have this new function called execute code. And now you can send code that didn't exist on the other computer, ever. And then run that code. Some code has been executed that calls a number of functions. And so now I'm making code up here and then running the code over there. And that is like, it's kind of the essence of like a Trojan horse. But in our case, if you're doing all this stuff, hopefully you're on a firewall. Anyways, you're at a big show, like they got some serious firewalls going on, like nobody's getting in your computers, but that should be given anyways. And hopefully you're not going to use this to go and steal your neighbor's whatever. But yeah, I like this. But it could be used. There's a practical use case. I haven't found it yet, but it could be used. So that guy, yeah, there's this guy. This is the ID Tools project. I'll make sure the link is up at the end. I'll go back over this because it gets out of the sync stuff. But there's some new Python stuff that I've kind of come up with recently that makes life, I like it. It makes things really simple. We'll go back over that.
What about this piece of code for real-time scene that you're running across nodes? Upgrading that scene?
It depends on what nodes, depends on what the use case is. If you're projection mapping, then you've got to run everything through sync. Because you're blending, you can't have any frame loss. If you're mapping on an LED with right up against each other, can't do it. If you're mapping TVs, you could probably do it. Like, you're talking like a frame possibly out. You can't perceive it unless you have a camera and you take a picture. And I've never been able to see it. So you could get away with a commercial license and not use sync. But in the case of mapping, you pretty much need it. I've had to do a workaround to be able to use this and some of the, I only really have one function I need to call, and it's start queue. Everything, and I need to send indexes, and those are channels, and you don't want to really be sending channel data across a message when touch is already doing that. So that's all C++ level embedded code, so there's no point in doing that. You're just adding extra overhead if you're actually sending channels that are variables. But if you're sending things that say go, or do this, or configure this, I'd way rather send a message than send some toggle that triggers a function that I have to look up somehow. So for now, this is mostly useful but for a VJ or live show scenario, any real-time control that's going to be the sync critical needs to be run through the sync chop. And I'll get to that now. But once we get that, once derivative implements that message over the sync chop, then we won't even have to worry about that, which would be really nice. It'd be a huge bonus. So yeah, okay, back to that controller. So right now, you've got these queues. And just look at a queue just quick. One with a movie in it. Okay, so that's a movie. So this queue, this is a movie. Oh, no, we're in the wrong node. Let me just go, here we go. Let's go into this node. Okay, so this queue's a movie. So it's got a notion of an index. Needs an index. I've run shows before without driving indices of movies, and just driving the frame of touch works perfect. Works perfect. I've left it run for 24 hours and still perfectly in sync. Because of the idea that there could be a problem, now I drive the index. There doesn't seem to be an issue either way. If they were to get out of sync with the former method, then there's going to be a problem. But if they get out of sync, you've got a problem to begin with. So that's a big problem. So either way, you're in a problem situation. But now I drive all indices. It's just for clarity. But no, sync works. Sync holds up touch's frame. So if you're using a sync chop, it's literally blocking touch until it gets the message to say go. Nothing happens. All those frames stay in sync. But since we don't want to have any error, period, we have the idea that there's master sync. So or not master sync, master index for any given queue. So now we've got this little queue comp, and it's got some parameters: queue, movie file, duration, speed, a few different things, cycle. I'm not setting that M frame. I just noticed that. I haven't bothered setting that. Now, what's happening is since we're in master, I've got this info.dat chop that's looking at the movie file. So this switch here gets switched. Sorry, wrong one. This switch here gets switched whether it's master sync or not. So this is in every queue. This is kind of fundamental. So if I am master sync, then I am the driver of the index. So that switch needs to be set to 0, and we're getting our index from the movie in top. If I'm not master sync, let's just minimize this for a second. If I'm not master sync, This switch is set to 1. Oh, I'm not playing. There we go. So if I am master sync, or not master sync, sorry, now, this switch is now set to 1, and now I'm selecting my index and exporting it or referencing it back to my movie. Reference. So I've toggled this index. Now I've switched this to specify index. It was in the other node, in the master node, it was set to sequential mode. And now in the slave node, right here, play mode is now set to specify index. The index is referencing this index chop. They both would technically the other one's not referencing the index chop because it is master, but that index can be coming from, it's coming from the sync chop eventually. And then there's another little override here, and this is if it's a Q comp or not. We'll talk about that in a second. But now what happens is, when you hit start here, you're calling getAdder in the parent, or in the top level parent, you're calling fplayers.getAdder, and it's now saying, okay, or qstart, sorry, you're calling getAdder, but you're actually calling the qstart function. So the parent is now saying, okay, or the master sync is now saying, okay, start queues, and since we have to run it over the sync chop, it's sending a function to the sync chop now saying, start queue. And you've already selected the queue though. In start queue, you've already selected the queue. So all the nodes now know what the next queue is. So you know that first. All the nodes now know that the next queue is the one you selected. When you hit start, you now tell all the nodes to start their queue. So if I go back to this guy, where are we? Okay, so we got queue start. So if I'm master sync, self.sync.par.qstart equals true. I had a problem just before the thing with the pulse parameter not cooking, and it was driving me crazy, and I thought it was all these other issues, share memory, but it was this pulse parameter like not updating in the par chop. So anyways, it's now a toggle, and I make it true, and then 5 frames later I make it false. So I just manually like on off, like, yeah, talk to you later, Brian. And so I turn that sync on. Now what happens is, if I go to sync, that extension resides here in sync. That toggle will get flicked on and off right there. We're looking at it. This selects sync sources. It's selecting that queue start. This trigger doesn't really need to be there anymore. That was trying to solve that weird cooking issue. It's not really doing anything now, but it could be bypassed. This turns off and on. This gets merged with all the other channels that need to be synced across the index of the current movie, the index of the next movie, not movie, clip, or queue. Yeah, next queue. And the master level. Those are the only 1, 2, 3, 4, 5 channels I'm syncing right now for the whole thing. So that gets sent out. They all just get merged. I just put that inside a DAT just to keep things cleaner. And since I'm in touch in, touch out mode right now. It's actually not going out the sync out chop. It's not there. It's going out this sync touch out sync chop right here. And since the preview needs to be in sync with the other nodes, the preview doesn't actually trigger itself, like within itself. It waits for the sync trigger as well. So it's in sync with all the other nodes because you technically want your preview to be in sync. So now we have this sync chop, and this is the one thing that bugs me, but will hopefully change. Now this queue start will toggle 0 to 1. This chop execute runs. I have a little list here of what channels it will filter. If channel.name in off on to off channels, get attr of the parent channel.name. So it's getting attr in sync extension. And sync extension has got should be at the top. QStart, yeah, sorry, so small, I didn't see it. QStart, so sync attr has got a function called QStart, which calls a function in fplayer in the controller called QStartSync, which is now different than the original QStart that got called by the button and told controller to start this whole process. And so we go back to controller now. So there's QStart, that was the original one when I pressed the button. Sent it out over the nodes, sent it out over the sync chop. Now QStartSync gets called because the sync chop toggled 0 to 1. Now Q equals self.ownercomp.selectedQ, self.ownercomp.playlist.currentQ equals Q, Q.start. So select the Q, make the selected Q, no, the Q is selected. Make the current Q the selected Q, start the current Q. Now, if self.ownercomp use Q cross duration, self.cross duration equals Q.cross duration. What that means is your crossfade is in the Q, not the global crossfade. So you could just have like a global crossfade, it's always 1 second. Or every Q can have a different crossfade. That's all that does. If self.ownercomp.node is master sync, if I'm master sync, self.cross.crossfade. Now this one's important too. Elif self.remote control, that means am I being remotely controlled? If I'm a node that's being remotely controlled, self.cross.crossfade remote. I needed two functions because the crossfade has to have one thing controlling the crossfade across all those crossfades. Like I can't just say to this one, oh go, oh go, oh go. Now they'll all be out of sync. So this one's got to be the master crossfade, and its cross has to be sent out over the sync chop and drives those other crosses. And that's not a big deal. You could just route that channel. That's not a big deal. But the problem is I'm A-Bing, and I'm switching who's being selected. And so it needs to know that has to be all in sync too. Like there can't be any screw-ups of like, oh, we got out of sync, and this A-B is opposite of that one. Now we're crossing to the wrong side. So if we go to cross extension, this guy gets called on the master. Oh, and there's another one in there too. If we're in the middle of a crossfade, don't crossfade, because now we could get screwed up again. Because like you can make it ping pong, but and I did that for luminosity, but it's not exactly trivial to start crossfading in the middle if you don't have all these hard bound channels, which you can't have because we're doing all this dynamic switching of who's selecting who. So the simple solution is if you're in the middle of crossfade, you're not allowed to crossfade yet until you get to the end. It's just simple. So if we're not at the end, wait till the end. Kill all runs and run again and see if you're at the end. And if you're not at the end, run yourself again, see if you're at the end, and wait till the end. And if you're done, then you can execute this guy because you just called yourself again. And now you're at the end of the crossfade. And then if you're the remote, you didn't have to care about any of that. You're just waiting for this to happen. And once you're remote, then do your whole thing. And then if you are actually in the crossfade itself, your sync, there's no switching here because it happened back in sync. But here's your crossfade trigger. If I was the master crossfade, this would all be just selecting right from here to there. It actually wouldn't be because it'd still be going through sync, but it'd be on the same computer, same node. But in either case, select from sync and then cross your val, and it's just going to crossfade that guy from A to B and this guy from A to B. But there's one other thing though too, still yet. We haven't set the sync selects. So rather than having every queue, like I did that, you could do that. You could be like every single queue has its own channel and then select itself in all the nodes. And now what happens if I have 100 queues? I have 100 channels. What happens if I have 1,000 queues? I have 1,000 channels. So rather than do that, I have 2 channels, A, B. So when you trigger a new queue, you change the path to the channel, to the selector in the sync of where you're getting your index from. And you can see that here. So these 2 guys here, select cross data comp 1, select cross data comp 2. So these 2 paths here. I don't know why I'm renaming that one. Yeah, I don't know why it's being renamed, but yeah, it doesn't even need to be renamed. But in either case, I'm selecting the current queue and or the next queue in those 2 index syncs. And now those are being selected by back again. It gets kind of convoluted. Back here in our select sync. And now my master queue is sending out over the sync chop its index. The cross controller has told the sync to select the proper index. That's being passed over the sync chop as well. And now all the slave queues are selecting their index and being driven. And then if you're running your own custom comp, it's the exact same thing, except you don't have an info chop because there's no movie file, and I just have a timer. And so here you can, the extension is selecting the index there, and that's going out to the sync chop. And if I was a slave, I'd be selecting here, I'm going to select that queue right now, hit start. So I have nothing here because I'm in master, but I have the index right here that's being driven from master, and if I'm quick enough, I move fast enough, I can get into here before it stops. And I'm selecting the index from the sync chop over there and driving the index of that animation comp for the node over here. So now it's just this, it's complicated to think about, and especially to start building something like this, you gotta like think about like, oh, and then you gotta like think about all these different things that depend on each other, and then come up with a solution that solves all those things cleanly. Meanwhile, you can't even think of all the things first, but you end up doing it eventually, and then afterwards it's actually quite clear. But it takes a little bit of thinking to well, first you got to go through the steps to understand the reasons, and then once you see the reasons and you're like, okay, I have to do this. But the hard part about it is coming up with a clean method. And to me, this might be a little bit much to take in right now, just like boom. But at the same time, like this to me is super clear. Like it's just like, okay, trigger a button, sends a message gets sent out over that message calls another message over here, tells everybody to do their thing like right now. That thing I got to do right now is tell me to go if I'm the goer, if I'm the pusher, the syncer, and then if I'm the syncer, go, and then if I'm the synced, select and be synced. It's just kind of like loop and then like that. And that's kind of that's pretty much the essence of the whole thing. Yeah, there's not much more to it than that. There's a lot of code, like there's a lot of little functions, like you could, like utility functions, drag and delete queues, and that all gets sent out over. It all uses that same getAdder stuff, like all the functions, like I could drop in queues, I could delete queues. I think we're missing one node. There we go. If I just hit start, so we're in sync again. Like all this, delete that queue, it got synced. It should if nothing's broken. I could delete this whole playlist, it'd be fine, hopefully. I can start a new playlist, I can add a couple blank queues, I can add a component, I can hit start, nice. So all those functions just got all sent across the network, and deleting, starting, stopping. these functions for the most part will as well. I think I added, yeah, not, I don't think I put a par execute in here. I don't think, let me see if I did. Par execute remote. Okay, so I'm bypassing controller here because this is outside of FPlayer. And I'm actually using op shortcut here. I know Jarrett's rule, and I've known it when I put this in here, and I decided to use it because I'm just like, there is not going to be more than one FPlayer. You can't have more than one sync chop in a project that's master, so it just doesn't matter. Just easier, but so now actually these components here, this should work. If I go like this, let's just see. Yes, nice. So there's the parameter of the field of view, which is being synced from the queued comp, and now that render, yeah, it's like 3 renders just being split, and it's all. You can see I'm using a touch in out. You can see a little bit of out of syncness, but I'm not using the sync chop there. Oh, well, this isn't in sync anyways. Even if I was, it doesn't matter. This is not in sync. This is just a message going to all the different nodes. But that works. And I think, yeah, this should work too. Yep, so now we've got orthographic. That has no ortho. Width is working. Perspective, nice. And, oh, I did a little other trickery here too. So right now we're cropping a 3D frustum here of the projection matrix. Can be a little trickier with 2D depending on what you're doing. Like this was not funny. Like this, I was a little bit not happy because I had to spend so much time dealing with this. But if you want to crop a noise chop top properly, you got to like deal with this period, and it's centered. So you got to like offset the center to the. You got to go into world coordinates or outer world. I don't even know. I can't remember. But basically, you got to do all these transformations to be able to crop this guy properly. So, and the only reason I actually kept on going is because I think we're gonna have to use a node. We're gonna have to use noise across a bunch of nodes in a project. So I'm like, I have to do this anyways. So this does work. Like if I do this, you can see here, 2D full frame. So that noise is 3 different noise tops, all cropped properly. And then there was one more here, which was kind of useful if you got some 16:9 thing you have to put on the screen, which is also not overly trivial. Oh, I selected the wrong one, sorry. There we go. So that's a 16:9. Yeah, so now we got a 16:9 render in the 20K render going across different nodes. So if you have to like output like some 16:9 content across nodes, the math is in there for that one. It was kind of easy, but it's a use case that's definitely used. And what else? I have a list. Just make sure, because there's some Python stuff, but I thought maybe configuration, sending data, render cropping, converting files. Yeah, that's basically the sync, the GPU download. If there's any questions or anything anybody has.
That the 2D issues was you're still projecting into like you'll see, so you did just the camera matrix or the
For the big noise, the colored noise? No, the colored noise, you have to scale the. There's this. Well, I didn't build the noise for one, so. But basically, this period and this scale. The scale is set to the width, and then it's adjusted aspect corrected to the height, and the period, like if you change this scale, it changes the scale, which is the exact same thing as the period, but not quite. But basically, you basically have to like, I'll show you the math. Like you have,
You create expression and scale.
I'm just selecting the expression's so complicated. I'm doing it in an extension. I'm evaluating it in a DAT, and I'm selecting the DAT because I don't want the noise top to run that expression every frame, because here's the expression. Like it's that for translate X. So I don't want to run that every frame, and it's not trivial. You basically, it is actually, but you got to take the canvas width divided by the node render size times the scale minus the node render offset X divided by the node render size width times the scale minus 2 times the node render size width times the canvas divided by the canvas width. So you're basically transforming from like a world space to a UV space back to a world space to get it, because they centered it, and you got to get over to the edge and you got to move it back.
Would it be easier to replicate the noise in GLSL?
Probably. Yeah, probably. But I just wanted to use the noise. If it was bugging me, so I was like, I got to get it. And it takes a while to implement. Although I have a couple noise functions, and it takes a while to implement all those. Like they got a lot of them.
I think there's a few in the palette as well.
Yeah. So you got all these. So I don't know. We're probably gonna have to use that noise eventually, like I said, for a project. So I got the math now. It's there. But yeah, the 3D is definitely easier. And then that's 3D is kind of a whole nother topic. To render a 3D scene and that whole perspective view. But this is the basic. If you have this, you basically got it all. You just, depending on what you're projection mapping, and you got a projection map, you have to know how to do that and all that. I'm just gonna grab a drink of water here quick. Pardon me? These ones I'm not preloading right now. Well, they are preloading because I'm dragging them in real time. But I haven't set this project up for startup. But it is on the agenda to preload when I select a new playlist. On startups, preload the current playlist, and then switching playlist, unload the previous playlist, and load the new playlist. And preload a new movie, depending on resolution, have a variable for the space in which to wait to preload the next, which is what I do in Luminosity. So you basically takes, like, for 60 movies, takes anywhere between 60 and 180 frames or whatever to preload a whole bank. Here would be a playlist. So I haven't done that for this, but it's pretty trivial to just run a loop that preloads every frame and unloads the previous. You got to keep track of the last playlist. But you want to keep track of that. Oh, that was one thing I missed here. You want to keep track of that, but also you want to keep track of what the last playlist was, so you can unload it. Yeah. This guy was kind of important if you're doing a live show. How much memory are we using per node? How much GPU memory? How much CPU? It's just talk back from the nodes. And then sync is quite important as well. Sync status. Process ID, if I want to kill every process or any process with, there was another thing I wanted to run down too. It's kind of good to check out. Address, machine name, project file name. Where's I don't even know why you need that in there, the op path. Include, yeah, it's part of the sync. Total timeouts, so most of those timeouts probably happened on startup, those 1,400 in each of those nodes. How many consecutive timeouts? How many total, steady total? How many steady consecutive? Oh, these are all old because I'm not running a sync chop right now. So these should be fluctuating if I was running a sync chop. But for the most part, if you've got a nice system that are capable to run all your movies, you're not going to get that many frame drops or anything. But there was one thing that's kind of useful that it would be good for people to dig into. It's pretty old code because I pulled it out of Luminosity, but this guy is good to use because nobody wants to rewrite this. Yeah, it's not fun. So I use PS tools. If we go into Fusion, Project, External Tools, you'll see PS tools, and it's pretty much like Windows. It's not an official Windows thing, but it's like all over the Windows site. So it's pretty much supported, or at least recommended by Microsoft to use. So there's another method with like the Task Manager or something, but you can't do what I'm doing here with that. You still got to do startup stuff. You can't like push commands to your nodes. So I use PS execute, and I do use PS kill, and there's another one. I don't use PS kill unless we have to, but I just use touch quit. But I thought there was another one I used. But in either case, if my node is okay, so if I hit that load all nodes button, if I hit load all nodes, here it is. self.opcop.config.run. I had to run this because it has to be delayed a frame, and I was having problems at that time with runs not executing within extensions, like calling your own, like it happens sometimes. So it's running a script. But that script then calls load node for every node, and that, or no, so no, it's a single, sorry, that's a parameter calling that. It calls this guy load node, capital upper camel case. So if we go to load node, here we go. Load node. If node.address is equal to self.master.address or node.address equals localhost, load local. If not, load remote. And I'll go through load local quick, and then we'll do load remote. So load local, load on the local computer. Here we go. Load local is pretty straightforward, but still kind of a little bit of like delimiting, like, so basically get your bin folder for your app for Touch Designer, replace all the backslashes, replace all the forward slashes with backslashes, get the project forward folder, do the same thing, get the project path, which is the folder plus the name. I did this a long time ago, so it's not quite as clean as it could be. If GPU is not equal to -1, set GPU for monitor whatever monitor index was set in the node. Else launch command equals just the execute.name plus nothing, just a space. Now here's the tricky one. popen command, which is a Python command, equals launch command plus project path. So the launch command is the executable name plus its arguments, and the project path is the project path and file name. Now, make some environment variables, mod.os.environ, environ node equals string of node, string of server, string of GPU for the 3 respective environment variables. Now pass, so you just set 3 environment variables like right there. Now pass, say P, so I can print it afterwards. Yeah, I don't think I even print it anymore, but you can, or get information from it. Sub.process.popen, the popen command, the command directory equals bin folder, so you're switching that directory. And here, oh yeah, no, you don't actually set the environment. I've just set them up to set the environment variables and then pass the environment variables to set upon that command. So now you, instead of running a batch file, just Python and just load the nodes. But this is the tricky one. So we encapsulated encapsulated a Windows command inside a popen command. So in this one, we're going to encapsulate a Windows command inside of a PS tools command and encapsulate that inside of a popen command. So we can send the command to a remote computer. So a bunch more of the same thing, basically. But now we have to do some raw string stuff because we're passing over the network. And, no, this is local, but I had to do raw string. I don't know why. But we're calling PS tools. So we have the popen command. Here's the PS command. This is the PS command, which has all that same stuff as the previous command. Then we're getting the external tools location, and we need the username and password for the computer we're going to send the command to, and then we make up a popen command, put all that together. Then we're going to run every 15 frames because we can't do it all at the same time because we need to, that's what that other script is doing. That load node is all happening 15 frames too. It's all separate because you need to set the environment variable, load the node, set the environment variable, load the node. And if you do them all at once, like you're doing it all at once, so you don't really know who's, like that environment variable only lasts a brief second. Like you kind of think that they're there the whole time, but they're not. It's only upon execution, and then it can change. But your node read it at that moment. So at that moment, it was node 0, GPU 0, whatever. So I do it every 15 frames. And we run mod.subprocess.popen and all those arguments to run the popen command, which is a composite of the PS command, which contains the Windows command. So that one's a super useful one for people to use because then you can just get rid of your batch files and you don't have to deal with any of that. And then kill remote node, that one's if I want to kill it, if it froze or something, I don't have to go into TeamViewer and kill all my nodes if I like some bug or something. But I have quit too, so quit just sends a message, calls project.quit. If you close that node, I think it should be fine, yeah. Except this playlist is now, I'd have to save this right now, which I could. I could save this. It's one thing, like there could be a little bit more robustness in that factor of a config file or those playlists automatically saving as a component, and those get loaded up on startup, so that way you don't have to worry about this. But right now I just like save the whole project. I can load whole playlists and load everything in, but I just haven't done that on startup. And now if I quit, let's see, let's just select. So if I go like this, settings, I'm going to fix this node list. It shouldn't say node 0 in here. But I'm going to quit node 1, sorry. So I can see my screen's blue there, yep. Now I'm going to load node 1. Hopefully this works. I'm pretty diligent about testing, like every time, like the other night at the talk, talking about bugs and stuff. I pretty much test everything every time. It's like you could break all kinds of stuff, especially when like in the controller stuff, like everything can be like anything could be broken. Like hopefully not if you did things well, but you're going to show a bunch of people and they expect it to work, or you got a user and the button's supposed to work. You got to test that. If you don't have an automated way to test it, then you got to do it manually. Yeah, so we're out of sync. Let's see what happens if I do it again. Yeah, we're still out of sync. Oh, no, we're not out of sync. This guy didn't get saved. This is an external component. So this field of view is different. Now, we're not, I don't know if I changed it. Yeah, see, we're fine. Good. Yeah. So I didn't save that component. That component was external component. But yeah, I'm pretty happy about this system because this system is it's simple. It covers a lot of use cases, which like a lot of cases there doesn't need to be more than one thing. Like a scene is a scene, a movie's a movie. I'm not VJing. Nobody's like queuing up 50 things at the same time. You start building systems like that, they got to be robust for like a live scene. Like you got an art director, you got a lighting designer, you're building a show, and if your shit doesn't work, it's not funny. Like, it's just like, so to me, simple, sorry, I can't do it. This is what I can do. It's way better than saying I can do it and then not being able to do it, or it's screwing up. It's like, so now it's just like, there you go. You want to play this? You want more than this? Okay, we'll add some more attributes. We'll add some more whatever. We're gonna make sure it works. But I'm gonna do what derivative does, and I'm gonna make sure that you really need that feature, and I'm gonna do my best to not give it to you until we determine you really need it. Because everything you add can break anything. That's my lesson. That's why this is, well, you saw it's actually not that simple, but it is actually quite simple. It's what it's doing is simple. There's not much to it, but there's a lot of points of possible breakage. What time is it now? 4:30. Any other questions about the GPU syncing? Hopefully it's going to be the exact same as the TCP/IP DAT, and I'll just say send message, send bytes.
Oh, so is it like some sort of like you can like drop like info on some sort of chop to get all this?
Oh, no, it's just going to be this. It would just be the sync chop, and you'd say op sync chop dot send bytes, and you just fill in that argument with some bytes. Yeah, and then on the receiving end, you'd receive bytes, and then you'd unpickle those bytes.
Yeah, but then you're talking about tables and like objects, and then
Yeah, you can send text. Text is the way I used to do it a long time ago. No, it's just, oh, you could. Oh, sure, yeah. Yeah, you can make you could delete every single operator in your project and make a whole pile of new ones. Yeah. Yeah. Yeah, you could. We were going to, the other day we had an idea that we could like sync everybody's computers. You could have big raster or something. And I was like, I don't know if that will fly. I need everybody's username and password. So we're not doing it. But any other questions on the GPU stuff?
basic question. For the nodes, are you copying this single tow file to them and they're running locally, or are they running
From the master. Yeah, first version of Luminosity, I had some like folders everywhere, and it's just a pain.
There's no reason.
No. Yeah, and all node configuration data is in a tox file, so that is unique to every node, each of those toxes. So now you could roll out some like I don't want to rebuild CamSnapper again, or Stoner again, so I'm just going to do it manually on my next one. But I do have in Luminosity like CamSnapper that can take like 50,000 points and go across the nodes. Stoner that crops and does stuff. But Marcus did some good new things in them both. The problem is it still doesn't take like 50 or 100,000 points, and it doesn't go across nodes. But I'm on my next jobs, I'm just going to TeamViewer in. TeamViewer just does a good job, like on a local network. It's just fine. So it seems to work fine for me. Yeah. No. Is it a good one?
It's been interesting. It's the way this works is really crazy. The distributed models out. They're just like the guys who want to control themselves. I don't know about files.
Oh yeah.
Pretty interesting.
Yeah. Okay, I'll take a look.
But we did it. We encapsulated them in packs. We didn't necessarily have trouble.
Okay. Sweet. So yeah, okay. If that's it for that, I got a few Python things that are in here that could be useful if people are interested in Python at all. Python tools. Just basically a couple things. Let me just quit these background notes just here quick. Oh, that thing's somewhere. There we go. So yeah, I have this whole thing with Touch Designer, and like my thing is like trying to make it run fast. Like I like making it not do needless cooks. So a lot of things is like if you look in this network, there isn't a lot to connect, but there isn't really even then a lot connected. Like it's just mostly extensions passing data around, and there's a little bit of connections in here, but that's pretty much the biggest component there is. So what I've understood now of Python is basically in this application, or in any application, when you load Python, if you're going to execute Python within the next application, you're making a new Python context every time. So I don't know if any of you know or not, but about a year ago, maybe a little longer now, Malcolm optimized expressions. And what that meant is he built his own Python interpreter that was not a Python interpreter, but was his own interpreter of Python-like strings. And so what he was able to do is not make a Python context for simple expressions like op dot whatever, or x2 plus 3, like a bunch of simple things like that are op dot par dot whatever plus op dot par dot whatever. Simple stuff. He made his own interpreter, so he didn't have to make a Python context, and those strings got parsed and called their own internal functions directly. And that took a huge overhead off of all those expressions, because for every expression in every script that gets run in Touch Designer, you get this overhead, no matter how small that script is, of this Python context being created, which is like, I calculated it once, and I think it was around like 35 to 50 microseconds. So for every expression, you're getting this like 35 microsecond hit for that expression that only took like 0.002, or well, 0.2 microseconds, 0.002 milliseconds. But the context took a while. So when I learned that, I was like, oh, you don't want expressions everywhere. Oh, you don't want scripts everywhere. You don't want par executes everywhere. And so then this is where I break away from the good practices that are being sent out, and I'm learning myself about more about like bigger level, not bigger level, but like I don't come from a programming background. I don't have a degree in computer science. I'm not like I've done a lot of things in my past, and they've all led to this now, but I don't have some of the basic schooling that a lot of people will get when they go to school for computer science. So now I'm learning some of these other more basic things for bigger level development with bigger teams, because I want to build a new application, and I've been working with more people, and it's just knowledge that I feel I need, because you start hitting these roadblocks. So one of the things I learned is best practices imposed on by other people are not necessarily the best idea. Not that they're bad. They're not bad. They're just not necessarily, like I'm the client right now. I'm the touch user. I'm the client. I have a problem. It's not really a problem, but I have something that I need to do, and I need to do it. As the person providing the solution to the problem, their challenge is providing me tools to solve my problem, not telling me how to solve my problem, giving me the tools to solve my problem. And so I'm in the same position now, because I have clients. And so I have to build tools for those clients that I have to solve their problem, or at least give them the tools to solve their problem. But it's not up to me to define their problem. It's up to me to understand their problem and provide the tools to solve their problem. So I'm kind of going off on a tangent, but it all kind of relates into this best practices thing, because I see a lot of problems with a bunch of workflows. And these are all great ideas, like everything. Like Touch Designer is like the best program, like program. Like I know Max MSP really well. I know Maya really well. I know multiple DAWs really well. I know like After Effects. I know those programs at one point in time. I've been like I've used it a lot. Like I could run most aspects of Maya pretty deeply, like in that. And I understood at that time that was the best program ever until I found Max. And then Max was like, whoa. And then I found Touch, and I'm like, destroys Max for a video. Like you could still say Max can do everything it does, but you can't do it as quickly. Not for video. But Max destroys Touch for audio. Like you can't do what you're doing in Max with Touch. It's not set up for it. So, but what I'm starting to understand is that when you build a piece of software, you have an idea first of what you want to build, and then whether you're a company or a person, you may have been asked to build something by somebody else, but you still have your own idea of their idea, and they don't even necessarily know what you want. They just have this thing they need to do. They need that piece of content. They need that thing. They don't care really about how to get there. They may say they do, but they actually don't. They just want the end product. And then you interpret that, and you're like, okay, well, I'll do this, and I'll do that, or you might make suggestions, but you might not be right. And if you're not right, you got to be prepared to, if you really want to, if you really want to keep moving forward and really fulfill those needs, you got to be prepared to let go of whatever you thought was right, because you're actually now wrong. And now it's like, okay, like if you could hold on to your guns and you could be like, no, this is the way. Or you could be like, okay, well, this is the way that I see works much better. Those were great ideas. And yeah, they may lead to other good ideas, and they may have led to this good idea, but they maybe weren't the best idea. And just because you thought it was doesn't mean it is. It's like, it's evolution. Everybody's learning and changing. So, long story short, exports are slow, expressions are slow. Python to Python to Python, execute dat to execute chop to par execute. Those are all overhead that we don't necessarily need. Like, it doesn't have to be that way. It's easy for a new Touch person to be like, oh, I'm going to connect that top to this, and I'm going to export that to that, and I'm going to make this circle do this. Or I'm going to take this component or this guy's thing, and I'm going to make some cool show event. Yeah, this is wicked. But if you want to build a big system and you want to optimize it to the fullest degree possible, well, you have two problems now. One, you've got to do it. And two, if you got to give it to somebody else, they got to understand it. So now you're in another position where you're like, oh, okay, so I could do all this stuff to optimize all this stuff. I could have one component in there it just works. Here you go. But then it's like, how does it work? So, and then you got to teach somebody how to make it work. So now I'm understanding the other side of that. So now you got to make things as fast as possible. But if you're not the only guy who will ever touch it, you've got to make it so the other people will understand it in such a way that you don't have to spend months teaching or days or whatever kind of time frame that's unacceptable to teach them. So that being said, you got that compromise now of being like, okay, this one function is going to call that function, call that function, call that function, call that function, all within one Python context, and nobody's going to know really what's going on unless they step through every function like I just did earlier. Or you're going to have those pars on a component and be like, this thing's selecting that thing. There it is. It's right in front of you. You could read the text. And you got that balance. So I'm trying to balance that balance with a little bit of both now. So it's like, okay, I'll use some pars. Like I'm not a big fan of pars. They're slow. Like storage is way faster. You're just writing to memory. Par is a class on a class on a class, or instance on an instance on an instance. It's like, it's overhead. So, and you don't need it. You're just storing data. Why do I need to store data in a thing called a par that's going to take like an extra 200 microseconds by the time I do all that stuff, and I got 50 or 100 of them? I don't need to do that, but you can't read it. I pass it to you. You're like, where is it? What's all this data? And if you're in a regular program, you're going to be like, oh, no problem. It's just a pointer to that. You're going to solve it. You're going to be like, okay, yeah. And it's going to take you 2 days. It's going to take you a while. But the whole point to this is things are faster. Otherwise, we wouldn't do it, right? So I've been thinking about that. So I built a few things. I got a few workflows that I've been doing. And first, before I go too deep, I'm just going to pull up these couple quotes I found because they say it a little bit more succinctly than I can right now. So first, we'll talk about a descriptor just quickly. So in Python. So in general, a descriptor is an object attribute with a binding behavior, one whose attribute access is overridden by methods in the descriptor protocol. This means those methods are __ get, set, and delete, and doc, it doesn't say here. If any of these methods are defined for an object, it is said to be a descriptor. So we won't go into the rest of that. So descriptors are basically keys into this derived basic Python type that from this derived, like all types are derived from this basic Python thing. I don't know if you call it a descriptor at this point, but they all have these functions called getter, setter, deleter, and doc, _doc, double doc. You see them once in a while if you're not too into Python or not as aware. You see __ init, __ class, __. Those are all, and this is one of the bad things about Python. It kind of bugs me that they put these in here because every time you say x equals 4 or x equals x plus 4, it calls 1, 2, 3 functions every single time. It calls the getter when you say x equals 4, or no, x plus 4, it calls the getter of x. When you say x equals x plus 4, the x on the left, it calls the getter. And when it sets x to equal x plus 4, it calls the setter, which is cool. But it's also overhead that somebody decided that we needed that. It comes back to that other thing again. So, but these are just understandings, like now getting into deeper levels of software and just communication and understanding of actual interface. But long story short, we have these 4 functions we can make use of. A property is a type of descriptor. Calling a property is a succinct way of building a data descriptor that triggers function calls upon access to an attribute. So a property now is a specific pipe into the descriptor of any type. And to set up a property the manual way, you would say property fget equals some function, fset equals some function, fdelete equals some function, doc equals something, and assign it to an attribute. So x equals this property and its name. Or no, there's the attribute. No, that's the value. Sorry. But this isn't the way that I would set properties. But this is the slow way of doing it. And here you've defined the functions. It's a slow way. You don't have to understand that or read it. Here's the nice way to do it. And that's to use a decorator. Put simply, decorators wrap a function, modifying its behavior. So Python has built these decorators. Hopefully we'll get to one quickly in here. 4 properties in particular. Okay, I can't find it fast enough there, so I'll just go to my code. Python's built properties, decorators, so you don't have to write all that code. So does anybody know about properties? Nice. So okay, so we got properties, and so this is cool. So you guys know. So I got a new level of property that I made that's specific to Touch Designer. So I'm just building to that. So what I like to do, I've got a couple things here. I like to do this with, like, you can use the TD store tools, and he makes all the properties for you that point to storage. It's cool. I don't use TD store tools too much. I like to set them myself. But I like to use properties to get to pars. Let's see if we can get to a par quick. A flare extension. Yeah, most of these got pulled out. Oh, here's one. So I like to bind properties to pars. So now I can have an F setter, I can have a getter and a setter on a par. Here's an F mode with a setter and a getter, or edit mode with a setter and a getter. So I just return the evaluated value for the getter, and every time I set that property, I set the par with the value. So it's just like the par is the data. But the real nice use case for them also is here. This is this color component I made at one point. And that's to make hidden properties. You don't have hidden variables in Touch Designer, so you can use a property to make a hidden variable, which is not technically hidden, but at least it's not accessible to the person on the outside as knowledgeably, or as just bluntly. So typically what I would do is I would use underscore. It's a kind of a Python standard, just one underscore before the attribute, and you might initialize it in init, and then later on you'll make a property that then updates that attribute. It might do something else. And in this color one, basically it's kind of simple, but it's kind of nice. Basically you change any one of these pars, and it sets the setter and sets the value of all these other pars based on its value. So any color, it updates the float version, the integer version, the hex version, and the HSV version. So you can edit any version, and it updates all versions by using the property to set the hidden variable behind the property. So you don't get this loop. You're setting the background ones. So this is in there. I don't want to go into it too deep, but you can investigate it. But it's this like nice way of just being like, okay, I'm adjusting lowercase r, which is float. Now I'm setting uppercase R and HSV and hex because I've adjusted the R value. And I'm setting them all, but I'm actually changing the par too, but I'm not getting a feedback loop because I'm not actually setting the parameter. I'm setting this hidden, this background thing that the parameter is referencing.
There's an example on the wiki about that.
Oh yeah,
There is a page for that.
for the par properties or for oh yeah, nice. But this isn't a par property now. This one here, this is a background this is a normal Python kind of standard one or use case, then connected to par properties.
I'm curious about two things that I guess. Because when you create a custom extension, just by default, it's boilerplate. It has like property stuff.
Yeah.
And also there's the more advanced use case of TD dependency, which is kind of interesting. I've used it in the past. I haven't had a problem with it, but it's still a little convoluted, but yet it solves my problem.
Yeah. Yeah, no, they're there, and what they've done is they made properties out of storage for the TD store tools. So those are turned into properties, and then you can also set those as dependencies, but you can also do that manually, just by using @property. And you can do that, and you can also just say tdu.dependency of whatever, and do that manually as well. And I tend to do that myself because I don't like importing TD store tools. It takes it's a huge module. And when you hit init, it's like every single time it's loading all those modules in every single extension. I just don't want that overhead. But yeah, no,
You can't put setters on it.
well, those are, yeah, those are their, I don't know if I set properties. I do set properties to storage, but not as often anymore.
So another thing, the thing that you're executing with the environment variable for node GPU, those kind of become global variables in
Temporary.
the project. Like if you were to go into the root directory local, I think you could actually see
Yeah.
GPU node there. So are you doing an execute script on starting the project and setting those to storage? And now I saw you have a custom class that says, like, fetch from storage, what is the variable GPU?
Yeah, I switch it because that variable changes. When you execute the environment variable, you say node 0 as an environment variable. If I'm loading more than one node on that computer,
Yeah.
the next node switches it.
Yeah.
If you go cook that variable, it's different now.
Yeah.
So you've got to, I store it in storage now, and I only reference from storage, which stays static for the lifetime of that project.
But so where's the execute? Just curious, there's an execute instruction that's setting it to start not launch.
Yeah, I have a start execute or an execute dat. Execute on start calls, execute start save calls parent.fplayer on start and on save. And then I have inside of here, system I think it is. On start. Set instance config. Set instance config right here. Self.ownercomp.var node, self.node underscore index equals int of that variable. Same with all these. These are all properties that get defined here. Yeah. Yeah. Yeah, so that's one of the use cases. That use case is a good one for the properties, but like this next one is a really good one that I find. Let's go back here, tools. So this little simple animation component. It's quite useful for some of the work we've been doing. And you basically just make a new channel, and you create a new channel, and you can set its amplitude. You can set its in-out. It's an animation component, but you don't have to set your keys. You could set its slope. I'm looking at this bottom blue one down here. You could set its slope in, slope out, all these things, and then you can cycle it. And then you can offset its time, and you can offset its value. And so it doesn't look like much, but it's actually super useful for a lot of use cases. You don't have to deal with all these like repeating like pattern chops and all this stuff. But what I liked about this, and this drove me to build a whole other thing, which is not in this particular component, but here's a really nice use of properties, I find. So this was a pain. I had to do it. At that time, I don't have to do this anymore. I've made it so I don't have to deal with this. So forgive this brutalness, but for every one of those parameters, I have this attribute that's not a property. It's just an attribute. And then I wanted this lookup for these names. But now I have these properties. Now this is the nice part. So every one of these is like its own little entity, right? Like this cycle, and then it just gets repeated. So that's like an object in itself, kind of. So what I've done is I said, I made a property called cycle key 1. And in that cycle, it's a list that is basically those 4 rows in the animation comp. And it gives me a start. I have a start index, its position, its offset, that's the amplitude of the very first key, and then its slope and its acceleration. All those things you see in the table dat of the channels in the animation comp. But then the next property is the previous. Well, it doesn't call it previous, but it's the next value over. So I move it over, and then I set the offset plus amplitude. So in the property itself, I'm setting the keys. Then if I go down here now I have a 5th property called cycle, which is a list of those first 4 properties. So now I've got a property that has all 4 of these keys in this one property. And then I have a property called cycles, which is a list of the number of cycles of that one cycle property. So I have a property, I have 4 properties, I have a property of those 4 properties, and then I have a list of that property, as many cycles as you want. Then I simply in here, there's a spot here where I take those cycles, or I take that property, I'm just like cycles. I just say X equals cycles or whatever. And then somewhere in here, I'm saying update channel. I have to find it, create channel. I don't want to search too long because I don't want to lose here it is. For cycle and channel.cycles, Now I just fill up the row with that property. And my property calculated everything for me on the fly every single time I called it. Or got it, I should say. Not called it, got it. So now every time I say, this is the really good use case. I do this with opt.find children and stuff all the time. Because now if you were to set opt.find children on init, or you just do it somewhere, you set it somewhere, every time you want to find the current children, you have to call a function that says opt.find children. But if I want a list that just says playlist, give me playlists. I just have a property called playlist that says return self.ownercomp.find children. So every time I say parent.playlists, it calls opt.find children, and I get all my children. And that's the bonus. That's, to me, is the real bonus of properties, because now you're getting stuff updated every time you get it. You don't have to go and say update this list, update. You just get it. The downside is you calculate it every time you get it. That's the downside. And that's something to remember. Every time you get it, you're calculating that you're going opt.find children. You might not see that, but you are. So that's what a couple of these things led to. So yeah, there's not power properties, storage property tools. Those are in touch. There's the regular Python method, and then there's using them for those functions. But now, this is what led me to this one now. Now this one, so what I like to do is I like to use those setters, because I don't like setting pars, and I don't like par executes, because if I have a function on an extension, I don't want to toggle the button so the button runs a par execute, makes a new Python context, and then runs a function. Especially if I'm not toggling the button, a human's not doing it. If this extension over here wants to run that function over there, and this is a context, this is already that 50 microsecond hit, and it's going to call a function over there. I don't want to toggle that par and break the Python context and then trigger another par execute and make a new Python context and add that overhead. I just want to set the function in that extension. So I'll use callbacks on those extensions, but then I can also use setters. But then how do you keep the par in sync with the property without calling the setter or the getter in that par execute? So it's this loop. So yeah, you end up calling it twice, or you end up just making that new Python context anyways, even though you didn't want to begin with. So it took me a little while, but I'm going to look at it here. I made my own descriptor. So if we go to par properties now, so this class here is called par property. Now this is not a TDU. It might be a TDU thing. Greg was alluding to that with the remote extension the other night. But this is now an actual descriptor that is overriding not a property, but I'm making my own descriptor. And now I'm overriding fset, fget, fdelete. I didn't do doc. I think I put it in there anyways. No, I didn't. So I'm overriding. We don't have to go through all this code or anything. But long story short, I made it so you now no longer have to say at property for my par, whatever my par was, at property define my par, return my par.eval, and then my par.setter define and set my par. This just does that for every single par in the comp. So you just load this module into the comp, or import it, and it just makes a par property for every single par. But that's kind of cool. That's okay. So now you got setters and getters, and they're all there automatically. But the key to this now is there's this callback system. So now you also have par callbacks on top of the setters and getters. So when you manually switch your par, you get this callback if you want it. That all you do is just type in the par name, and it calls a function based on that par name. But it also has a function. So if you set that par with the Python set, like if you set the par, if you set the property, if you set the property, it will change the par, turn off the par execute, and call the callback. So now you get, when you switch the par, you call the callback. When you set the property, you call the callback, and none of it happens twice. And so you have one Python context when you're setting values, and you're updating pars if they need to be updated, and you're able to use pars to call your functions. And it seems convoluted on a certain level, but at the same time, it's quite useful. And I just have a few examples here. Basically, I put all this code in. You guys can dig through it later if you like. But basically, you just do this line at the top. You import par props, or you import par properties, assign it to par props, and then you call par props.par properties, and you pass it self, and you pass it a dat where your callbacks will be, and then that's it. Like all this is just extra stuff, just as an example. And then you have a dat sitting here called par callbacks, and I just made these just as examples. So these will get called when you set the property or change the par. And I actually left the module right in here, so it gets imported right from there. And then you have this one special par execute that just has these two lists, these two attributes it checks. And they should be there in order not to get that double call going on. And so now if I was to go like this, if I hit parent.play equals not parent.play, I get that one callback called. If I hit parent.q, I get that other callback called. Parent.float, I think I should have changed that. Changed something, I think. No, it's not. I have it. It's I think that's create float part, self.float, float getter. I haven't checked that one in a while, but parent.float equals, do I have a float par though? Oh yes, I think I have to go like this. Oh. There we go. Yeah, so now I'm setting that par with that property. And I'm not calling the callback when I'm setting the property. I'm calling the setter. So there's no par execute happening. So they're being used in Fusion quite a bit, like under the hood. And what I'd like to do is directly hook this into that remote function, because if it was hooked into remote, then you wouldn't even have to think about that. That would be kind of nice. The whole point was to like not think about these things. And so really all this extra stuff here is just like examples, but the only thing you really need is that line right there and that line there and a DAC called par callbacks. And it's a little bit like it's hard to see the reasons behind it potentially, but you can see it here. So now I'm hitting start and I'm calling that callback, and then I'm running start and I'm calling the same callback, but I'm not calling it twice, and I'm not using a par execute when I'm running this, which I personally care about. And that makes it so I can stay within, like I could have functions, calling functions, setting properties, doing whatever, and all staying within that one Python context, like a regular program, rather than the touch kind of like switch this to switch that to switch
Be
this.
opening up new ones every single time.
Yeah. Yeah.
I mean, I'm a little bit, I think my understanding happens a little bit low, but I gotta improve things a little bit, so I'm gonna like maybe make a metaphor, see if I'm starting to get that. So is it, we kind of use this first par execute to enter this kind of chain where you're able to just kind of like par executing, these getters and setters can terminate these same instances in Python from one thing to the next and close it.
Yeah, you basically have one thread of execution. We're not really talking threads, obviously, but you have one series of executions.
And then by automatically deferring on the properties from the goal that visible persistent
Yeah.
that whole
Yeah.
basically.
Yeah, and then the key factor is now is the really nice use cases is the par callbacks and the par setters being combined in one. So now you don't have to like write a callback. You don't have to have a callback mechanism that you got to like implement. And you can use a setter. You can use a setter just like you would if you use that property, but you also have a callback and they don't conflict.
Is it like when you're automatically doing that, you make some sort of like observation?
Well, you can observe what's going on. Like that's what I was doing with this printing. Like I'm telling you what I'm printing there, what's happening. But mostly it's meant to be just run in the background. So like I'm telling you, it has been, start has been set to false. It's been called, and this is where you really see it too. So if you actually read this line. So here, let me just clear this. This is kind of gives a little clarity. So run that script. I'm setting the setter. Start property has been set to false by tools example par properties example extension dot example parse extension object. So by the extension called from example2 tools example par properties. So that's the comp. Now, so that was from running the script, right? Now if I go like this, start has been set to true by the extension, because it's still running through the extension, because the extension's handling the par properties, but it was called from par execute par callbacks, because I switched the par. I didn't run this, I didn't set the setter. And neither of them called each other, like, which was the problem.
Even because your property is linked to the parameter, so nobody would have called.
You'd see it twice. Yeah. Yeah, which could be all right, like it doesn't matter, but if you're actually doing something that was like switching things, maybe like things could go wrong. So that was a kind of a useful one, and then another one, I won't go dig too deep into it, but for anybody who wants to dig deeper, it's going to be in this project. There's this Overong project. Let's just go back here. That led like those two components, the colors and the animation curves, and some other ones. They I like to use objects quite a bit now. Like just make your own object, make a class, make an instance of the class, do a bunch of stuff with it, but you can't store it, right? You can't put it in storage. Like you could store a component or a par, that won't break touch, but you try and store your own custom object and then save your file, you get that pickling error. Cannot pickle, all that. So like those two components I was just at, just a second right here, these are both objects, like they have a color object and a channel object, and you can't store those. So then I got to make this thing that goes and reads every attribute and then makes a dictionary key for every attribute, and then I can store that. And then I can take that storage, I got to convert that back to an object, which is fine, like you just do it. It's kind of a standard thing, model to data. But I was like, so this could be useful. It's quite deep, but I won't go too far. But I made this thing that basically goes through your component, or not component, goes through your class, your instance of your class, tests every attribute to see whether you can serialize it, and if you can't, goes into that object and tests every attribute of that object and sees if you could serialize it, and if you can't, goes into that one and just keeps going until it gets down to ints, floats, strings, lists, or dicts with only ints, floats, strings. So if you can serialize it, it stops. And then it parses that all out to a serialized dictionary that you can then load into a JSON, dump into JSON. And then you can save that to disk, you can save that to storage, and then you can say JSON.loads and do the opposite back and rebuild your object. And boom, you got all your attributes set with all these custom objects without having to do anything but call these functions. And so it takes a little getting used to. Like, this is just this mammoth script that I wrote. So some stuff's commented out, but basically you've got this one position class. You've got some static variables here. C equals 3, D equals position, a couple other static ones. These are all just little test things. Then inside of init, you have some instance level attributes. Some ints, some floats, some lists, some tuples, some dicts. Then you've got a couple that aren't set to anything for testing purposes, that are going to be used as properties, the underscores. Then you've got some that are positions, so now these are objects. And then you've got some lists of those positions, so those are lists of objects. You've got some tuples, and now you've got some lists of tuples and tuples of lists of objects. And then now you've got some dicts that are lists and dicts of tuples of objects. And I just kept on going down, so like testing till like how far you can go down. Then I got like TDU matrix, make sure that's gonna work. Later on, I have some par properties and regular properties. Make sure those are going to work. And so a property doesn't. You can't set the prop. You can't save the property because the property is just a pointer. It's not really a pointer, but it's just a reference into the attribute that does stuff to the attribute. So you can't really save the property, but you can save the attribute. So you got to dig down into that. And then you have some functions. I think I have a list of functions somewhere. Maybe not in that one, but you got another special case if your attribute is a function or a list of functions. That's like another use case. And then, yeah, so there's some properties there. So then I go and I make an instance of my class. That was called my class a second ago. I set a bunch of attributes. I set a bunch of attributes of some of the lists because I want to prove to myself that this is working. Then I make this thing called instance1data. So instance1.getAtters. In this particular case, I'm inheriting my object data module. You don't have to inherit it. You can just use it and pass the instance that you're trying to get the data from. But in this particular case, I'm inheriting it. So instance1data, I get its attributes. I put them into instance1data. I print them just so I know I can see them. I dump them to JSON. Print a little bit of space, a few lines so I can see what's going on. Instance2 equals my class, so I made a new instance of the same class. Delete a bunch of attributes. I want to see that it really works. So I just delete like a pile of attributes, like they're no longer part of the instance. Print instance2. Actually, I've done it. I don't print the whole instance. I don't print what's going on there. I did at one point, but I'm not right now. Just saying that I set instance2. Now, instance2.setAtters JSON.loads instant1data JSON. I converted that instant1data up here to JSON right there. So now I'm taking the JSON payload, or not payload, but the JSON object and setting it to instance2, all its attributes. Now I get instance2 attributes because I want to see them, and I print them. And then what do I do? Oh, and then I do a test at the end. If not instance atters equal, find out where it wasn't equal, but right here I say instance atters equal instance1.getAtters is equal to instance2.getAtters. So that tells me right away if instance1 equals instance2, then everything I just did is correct. And if not, then tell me where it's broken. And so now this just pumps out this huge deal. and this JSON payload now, I made this dictionary called an attrdict. It's my just name for a dictionary of attributes. And it has a type, it has whether you should set it or not, and it has a value. And so you just got this giant dictionary of dictionaries of attributes for that entire object. And you can just see it, it just keeps going down. Now we're all in the lists of lists of lists, or dicts of lists, or whatever. Keeps going, and then right about here, we're at the halfway mark. Okay, so that was the first one. Now I'm setting instance 2, initialize instance 2, set instance 2, get instance 2, print instance 2, same thing. I won't look at all the values. You can see them all, though, if you really want to dig in it. And then at the end, instance 1 is equal to instance 2 equals true. So it worked. So that it's a little bit like, whoa, why did I need this? But for those 2 components previously, all the work I did to like get it in and out of storage, I don't have to do anymore. All I got to do is call this thing, just put it all in storage, bring it all back, or write it to disk or whatever, and we're good. And then there's some more tests down here to make sure my par properties work with it, because par properties broke it at one point. And then you could test all these ones too. But I had fun doing it. It was like, it hurt my mind at one point to deal with it. I was like, stuff like that I like doing, because like it's hard to make work, and then you want to give up, like you just want to give up. But if you don't, and you can see it through, I have a big description at the beginning, but it just basically gets into the class. Well, those are my own kind of things. Rob and Selena gave me a pointer. I should change those names a little bit to exclude. You can exclude attributes or include attributes, that kind of thing. But you basically get into the class, get into the module, get into the instance, depending on what you're doing. And you just keep digging down. I won't go through all this step by step, because although I enjoy doing it, I had to do it myself. Every single line, I'm like, about 4 or 5 times now, I've like gone over it. This is doing that, because it's so confusing. But it basically just keeps calling itself until it gets to the bottom, float or string. And then once it gets to that, then I know that that entire hierarchy of whatever it was serializable, and I can now put that in a dict, and we're good. But if any of you guys want to actually use it or explore it, it's I tried to be pretty explanatory. Maybe I should put some more notes in here. But the names are pretty self-descriptive. And basically, it just keeps, you can go over just quick. Get attrs, if not instance, instance equals self. So this just checks if it's inherited or not, or if it's calling itself. If it's the instance, if it's the original instance, then it's got to do something slightly different. It's got to filter things. So make this attr empty. So for attr name and attr val, an instance of underscore dict underscore dict underscore dot items. So the dictionary of the object, which is all the attributes of the object in Python, like the actual Python attributes. Go through each of those attributes, get its name. If attr set equals attr name not in self.filter set. That should be exclude. So if it's excluded, don't do anything. Don't set it. Create key just sets this key up to begin with. If has attr, okay, so we're just still checking to filter or not. So here's the important one now, or getting into more important. If attr.val underscore class. So if the class and the module that the class belongs to is not in TD or TD.u, we can keep on going. If it's in TD or TD.u, I got to change what I'm doing. And now this is the big one. This is the important one. I'll stop after this. If not, self.is serializable. Is the instance we're currently working on serializable, which is a function that checks if it's serializable. Of that value, attr val, try serializing it, except print. So at that point, Yeah, so do it again. So serialize calls this whole thing again. So if there's an error, go here. But serialize calls this whole thing again. And that keeps getting stuck on that and keeps going in a loop until it gets to something serializable. That's the loop right there. So serialize is going to call this again once it gets done. And then it just keeps doing that, and then you end up with that result. I'm not going to go through this. It'll take like half an hour. But if you guys can use it and start using objects in your code and then start dumping your objects into JSON, it's a pretty huge bonus because now you can use objects. And you're not just using dicts and lists. And objects can have whatever hierarchy. There's one more feature that Rob mentioned that I didn't know about. There's this .s attribute of all most touch objects that I got to use because it will just provide me a serialized list or serialized data of whatever object that TD or TDU object was. So I never knew that until after I talked to those guys about it, but I think it was .s. Well, that is it. .get state, .set state.
It's defined for a few of the built-ins, like parameters, channel value,
Yeah. So we got to put that in there at one point. But to me, I'm stoked for that. Next time I got to build a component that has objects, I'm just using it, and I don't have to worry about storage anymore, or JSON payload or whatever. It takes a little bit to wrap your head around, but those examples, they all kind of give the full deal in there. Oh, if anybody wants this, I didn't share it in the email. I can send it out on the email, but the link to it is right there. It's the same link as before, except instead of the repo being Fusion, it's ID tools.